2.1 functions and the function notations. In this section, we are going to define relation, domain, and range, understand the concept of the function, determine whether an equation represents a function, find the domain of the function, evaluate the function, and solve the application involving function. So we start from first one, relation. A relation is a set of order pair. The set of the order pair, that is a relation. Order pair. So the set created by the first components in the ordered pairs is called a domain. So when you have a set of the order pair, so this is the x-axis, this is the y-axis. So the x term represents the number on the domain, and the y term represents the number on the range. The set created by the second component in the order pair is the range. Find the domain and the range of the relation. So each order pair here that represents a relation. So this relation has the domain is 2 and the range is 7. So the whole set here, the whole set of the order pair here, all the first component that represent the domain. So 2, -3, 5, -10 is the domain. The second component, 7, 13, -11, 13. Since the 13 has to represent one time, we don't repeat the second time. So you only represent the 13 one time. So this 3 is the range. So the previous representation is an order pair. We also can represent the relation as a mapping. We call this as a mapping, and it comes with the arrow direction. So there's a 2 oval shape here. The left hand side oval shape that represent the domain. The right hand side oval shape that represent the range. So the domain has A, B, C, and the range has W, X, Y. So A pair with W, B pair with X, and the C pair with Y. On the part B here, the domain has 4, 5, 6, and the range has 3. So your 4 pair with 3, 5 pair with 3, 6 pair 3. This is okay. It's the same idea like I have these 3 students. 4, 5, 6, they are all my students. And at 10 o'clock on Monday, they'll come to my classroom. So this is okay. This type of the representation is acceptable. This one is okay, of course. I have the individual domain paired with the individual Y. Now, function. What is a function? Any relation that assigns exactly one output value for each input value is called a function. So in other words, for each input, there is a particular output. So each input has a particular output. We call this as a function. Since the value of y depends on the number of x, we call y is the dependent variable and the x is the independent variable. So your y is rely on x. If you tell me what is the x value, then I can plug in the x into the function and solve for y. So y is the dependent variable, x is the independent variable. And sometimes we call the x is the input, and the y is the output. So the thing you need to know is the definition of the function. For each input, there is a particular output. This is a function. The variable x and y is the dependent variable, x is the independent variable, y is the output, x is the input. Now we look at here, function. A function f is a correspondence between a set of input value x and a set of output value of y, where to each x value there corresponds exactly one y value. So this is the function. Domain, the mean, is a set of input value of x. We call it domain, which is your x-axis. Y is the y-axis. Sorry, range is the y-axis. How do we determine the equation represent a function or not? We look at example A, 7x plus y equal 5. So we rewrite the equation into the y equal, okay? Y equal negative 7x plus 5. Now, this is a linear function. You have a slope number is negative 7 and the y-intercept at 5. So this is a linear. So yes, this is a function. Look at B. Y is equal x with absolute value plus 1. So when I rewrite the equation, remove the absolute value, it turns to a positive x plus 1. So y is equal x plus 1. This is it turns to a linear function as well. So yes, this is a function. Y squared equal x plus 2. So when I solve for y, I get a y is equal plus minus root x plus 2. So when you have y is equal plus minus square root x plus 2, you will have the graph turn to like this, plus minus, okay? So this one is not a function because I have the double sign here. So in other words, as long as you rewrite the equation into the single y on the left hand side and the right hand side, if you have the two different signs in front of your right hand side portion, in that case, that won't be a function. If you look at the A, we only have the single negative sign, so this is a function. Example B, we have the single positive sign in front of x, so this is a function. But now the C, I have the double sign in front of the x term, so this is not a function.